Okay, so one thing that I absolutely hate about our book is that I don't think it actually makes very clear that you have to deal with the lower limit too when you're doing the second fundamental theorem of calculus. But every example that I've shown you so far, the lower limit ends up being 0, or taking the derivative of a constant would be 0, and therefore it goes away. But I'm going to show you what I mean, okay? So, but if there is a variable or anything down there, you actually have to consider it too, okay? So for example, let's say you have capital F of x equals x to x plus 2 f of t plus 1 dt, all right? And they want you to take the derivative of it, okay? So you take the derivative, you take the x plus 2 and you plug it in for t, okay? And then you have to take the x and you plug it in for t as well, because this is a variable, not a constant, okay? So you plug that in, okay? Now, you would have to multiply both of these by the derivatives of these, okay? But the derivative of x plus 2 is 1 again, so multiplying by 1. Derivative of x is 1, multiply by 1, okay? Alright, so when you simplify it out, you get 4x plus 8 plus 1 minus 4x minus 1. Don't forget you have to distribute this negative, okay? Some of you are bad about that. So then 4x minus 4x goes away, 1 minus 1 goes away, and you're left with 8, okay? You could do the same process with the number on the bottom, and this is why you don't ever see this step, okay? So let's say that you have a problem where it goes 2 to x plus 2 f of t plus 1 dt, and they're like, hey, use the second fundamental theorem and take the derivative, okay? So the reason why you only see this part is because what happens over here. So you plug in the x plus 2 for t, multiply by the derivative of x plus 2, which is 1, okay? Minus, now you're going to plug in the 2 and then take the derivative of 2, but the derivative of 2 is 0, so this whole thing's going to go away. So you're just going to solve this part out and you get 4x plus 9. So whenever there's a constant down here, the second fundamental theorem just kind of leaves this off because it's going to go away, all right? But I want you to see why.